Hello boys and girls, this is Mr. Kizik, and in this video we're going to be looking at what are congruent figures. So congruent figures are polygons that have congruent corresponding parts. In other words, when we talk about the parts, we're talking about the sides and angles. What also is important is when you name congruent polygons, you must list corresponding vertices in the same order. So let's look at an example of what we mean here. So in this first example, we're going to have this drawing here, A, B, C, D, and this drawing here, F, E, G, H, and it says figure A, B, C, D is congruent to figure E, F, G, H. And the problem asks you to name all congruent corresponding sides and angles. Well, let's start the angles. So angle A is going to be congruent to angle E. Angle B is going to be congruent to angle F. Angle C is going to be congruent to angle G. And angle D is going to be congruent to angle H. Now, if I'm talking about the sides, though, if I start with, say, like AD, it looks like AD is congruent to EH. Likewise, if I continue, it looks like AB is congruent to EF. You could say FE too, and remember, that doesn't matter. Then I'd say it looks like BC is congruent to FG. And then it looks like CD is congruent to GH. So look at the picture here. We were able to name the congruent corresponding angles and sides. But what happens if you didn't have a picture? And in fact, a lot of times in geometry, the picture is going to be deceiving. That's where the naming comes to play, because if I look at how everything was named here, if we talk about the angles, angle A matched up with the first letter of the second figure. B matched up with F. C matched up with G. And D matched up with H. And the same could be said for the sides. AB matched up with EF. First two. BC matched up with FG. Middle two. CD matched with GH. Last two. And then what I like to call the connecting points, AD match up with EH. So in fact, sometimes it's actually better, well, not sometimes, all the time, it's better to use the naming when talking about congruent parts because the pictures could be deceiving. So let's look at another example with just naming. So let's just say, for example, I said triangle WYS is congruent to triangle MKV. One thing to note here is that in this chapter, we're going to be dealing with lots of triangles, and when we name triangles, we put this little triangle symbol in front. So if I want to talk about congruent corresponding parts, let's talk about angles first. Angle W, first letter, matches up with first letter of the other figure, so M. Angle Y is congruent to angle K. and angle S is going to be congruent to angle V. Now if we talk about the sides, first two, WY matches up with next two, MK. YS, next two, match up with next two, KV. And then the connecting points match up here. So not only does the naming, that tells you what parts match up, when you're given the actual pictures in geometry, not everything will be labeled. So in this next example here, we're going to look how that happens. And in fact, what I'm going to draw for you guys here, I'm actually drawing more than what I should be drawing here. So, you know, not that good of an example, but still a good enough example where we can see what won't be marked that we'll need to remember. So let's pretend these things are marked here, this was marked here, and this was marked here, and this was marked here. And basically the question asks you, are these two triangles congruent? ABD and CBD. So remember, in order to be congruent, all sides and all angles must match up. So with the sides, yeah, we got AB matching up with BC. We got AD matching up with DC. And the last portion here is, well, what about this middle line? You know, what about BD? Well, if I think about this logically here, and I disconnected these two triangles, by definition, BD has to be congruent to itself because it's part of the same triangle here. So now, so again, that's one of those things where it's never going to be marked for you. You just need to realize it's a shared line. They are the same. And there's going to be a reason why that is true when we get to proofs especially. So let's talk about the angles. So angle ABD is equal to CBD. We have this right angle on the right triangle here, angle CDB. We know then that on the left side, it has to be also a right angle. So ADB. So now the next thing is, what about angles A and C? Well, the short answer is yes, these two are congruent, because if you recall back when you first learned about isosceles triangles, because yes, this is an isosceles triangle, the base angles here are congruent. So angle A is congruent to angle C. So therefore, everything matched up here. 3 pairs of angles, 3 pairs of sides. So we could say, yes, they are congruent. Now, if we're doing the naming, let's say we name triangle on the left ABD. That means on the right side, I have to name the triangle CBD because all the vertices match up. Now, let's say you didn't remember that the base angles in the isosceles triangle are congruent. Well, there is something else in geometry that could have helped us here, called the third angles theorem. And the third angles theorem says this here. It says, if two angles of a triangle are congruent to two angles of another triangle, then the third angles are congruent. So 2 angles of one triangle, the same 2 angles on another triangle, then the third angles must be congruent. So what does that really mean? Well, logically it means this. Let's say we got 2 triangles, and I say these 2 angles here are congruent to these 2 angles here. Let's say now we throw in some numbers. Let's just say this was 60, that was 40. which means then this has to be 60 and this has to be 40 because they match up. Well, what do we know about triangles? Remember, triangles add up to 180 degrees, no matter what kind of triangle it looks like. So if I do that concept, well, 60 and 40 is 100. That means this angle has to be 80. Same logic is being applied over here. The same two numbers, 60 and 40, this also must be 80. So this is something else here that we have to keep in the back of our mind, because if two angles are already labeled for us, that they are not going to label the third angles for us because of this theorem. So let's look at another example that utilizes this and something else we have learned. So if I look here and I drew this figure, A, B, C, D, E, this marked, that marked, 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 marked. And of course the question is asking you, are they congruent? Well, let's actually start with the sides first, because that's the easiest. Because this tick mark matches up with that single tick mark, that double matches up with that double, and that triple matches up that triple. So all the sides are congruent. But what about the angles here? Well, we know angle A matches up with angle D here. But what about the other two angles? What about E and C and then the ones in the middle? Well, think all the way back to chapter 1. What kind of angles are these that when they cross they form an X? Remember, these are vertical angles. Again, something else that we'll need to remember from previous chapters, because they won't be marked for us, but they'll help us solve for different problems. Well, now all of a sudden I have those two angles congruent, and now I have two angles in each triangle congruent to one another, which then means by the third angle theorem, these two angles must also be congruent. So the angles also all checked here, so therefore the two triangles are congruent. So we could say something like triangle, ABE is congruent to, and how would I have to name the other triangle? It would have to be DBC. But I didn't have to name it like that. I could have named it, say, EAB. So therefore, how would I have to name the other triangle? I would have to name the other triangle CDB, because again, the vertices match up. And that, ladies and gentlemen, are congruent figures. So the important things to take away here are that every single part of your figure, no matter how many sides you have to all match up to each other in order to be congruent. The naming is very important, because that means the vertices match up here. And then when it comes time for the drawings, there's going to be stuff that we have learned in the past and that we'll be learning in the future here, where it won't be marked for us in the drawing, but we'll need to know about it in order to mark it ourselves. So, ladies and gentlemen, your homework will be in that worksheet that was given to you, numbers 1 through 10. If you have any questions, make sure you email me. You see me during school. This is Mr. Kizik. Sign off.